So we're going to go into the last part, which is the core Python stuff, which I'm just kind of closing up little tabs here because I have so many tabs open right now. I just want to make sure you didn't. Okay, core Pythons, or core Python basics. All right, so this is where we're going to go through a whole bunch of stuff. This is kind of going to bleed into our office hours. This technically will start going into like the end of topic 1, maybe into topic 3 technically, but I think it's useful to just go through it. We're not going to go through the whole thing. We're going to stop at before control flow. So we'll actually go through data structures and stop at 4. We'll save control flow for another time, just because there's a lot to go through. And we've already spent, I don't know, almost 2 hours, right? So I'm sure you guys would like a little break. And then we'll go into office hours if you guys want. So objectives, we're identify different data types, identify different data structures, and we're going to find how to use different control flows, not for this time, the next time. Okay. So some data types, right? So in Python, we have things called a string and integers and floats and stuff like this. So you can see in this case, this is a string. Okay. And a string, basically, you can think of it as like, a string of letters, something that's supposed to be like a text item, right? And note that we can use single quotes or we can use double quotes, right? Python is totally cool and chill with using either one of those things. We also can set, like, again, you guys know what variables are. We can also set things like our floats, and our floating is a floating point number. So basically anything that's like a decimal. Okay. Yeah, if you're not talking, if you can put on mute, that's cool. No worries. Okay, and then we also have integers. If you remember back in your math class, integer basically is just a number that has no decimal, right? We can have negatives, positives, right? 0, all that good stuff. We also have something called a Boolean. You'll notice that I put this right here because this is a reserved word called bool. So I didn't want to erase the word bool from Python, so I just put false. So note that false or true, right? And note that it is capital, right? If you use lowercase, it will not recognize that as a Boolean value, okay? And note that those are your 2 options. You can either get true or you can get false, okay? Is your Boolean, very practical in computer science. And then Python also has something called a none type. This is equivalent if you had other programming languages like null. Basically, it's saying like there's nothing here, okay? So this kind of gives some extra interesting stuff going on here, but we can run this code here. And oh, I don't know if I showed you guys in Jupyter Notebook. You can either click this run, which will run this one cell that's highlighted, or if I hit Control Enter, it'll run that cell by itself. Or if I hit Shift Enter, it'll go to the next cell, right? And then ready to run. So you can see here, this you saw 1, 2, and then 3. This is basically saying, oh, this is the 3rd thing that was run. So that's what it's keeping track of. So this next one, when I run it, will be 4, okay? So if I run here, for example, string 1, what is the meaning of life? You can see it gives me an output in this case, what is the meaning of life? And that's because Jupyter Notebooks are smart enough where it's just, if you have that variable at the very end, it just knows like, oh, at the end of the cell, it's like, oh, just go ahead and print that out, okay? Note that we also could have done print, but you notice it's a little bit different, and that's because technically Jupyter Notebook uses something called display to display that string, and you can see that's what that looks like right here. Okay, cool. All right. Any questions about strings, floating point numbers, integers, booleans, none type? Sound pretty? Hopefully there's nothing too new for you all. Okay, cool. So one thing you might want to do is actually to be able to check the type of a number or your variable. So you can actually do type. It's like a function type, and then your parentheses and a number. So this is us calling the function, right? And we're saying, hey, tell me what this type is for this variable. In this case, this is actually a floating point number. Pretty cool, right? If I do like, let's see here, another number, int. Okay, so you can see that right here. If I put n here, which was none, you'll see it's a none type. So it has its own special type. We can also put in, let's see, bool. You can see it's a bool, right? That's why I didn't want to replace it with a bool because it would actually get upset. But yeah. Any questions on that?
Quick question.
Yeah.
This is Chuck. So once, in this case, you haven't declared the type, like let's use number. So I forget what it was. Was it decimal?
Float.
Float. So so Python is, looking at what the contents of number is, and it's coming back and saying it's a float. At that point, is number variable always treated as a float? Or if you reassign the value to be, say, just 42, does it switch over to being an integer?
Good point. Yeah. So this is where I get to go a little computer science-y too. And you kind of know about declaring, right? So for those people who have used another programming language besides Python, you might see something like, for example, if you use like Java and C, you might see something like int, right? And say like, oh, this variable will be an integer variable. Python has kind of that kind of hidden within their part, but Python is built around this kind. Trust me, this kind of answers your question, Chuck. But Python has this built-in way of dealing with variables, and the idea there is that the variable is kind of like people talk about it as boxes. I don't think it in Python. I don't think that makes as much sense. A variable is more like the computer points at saying, "Hey, where is number? Where is the number variable?" And it points to the number 42.0. And then if you change the variable, like you were saying, Chuck, if I do number equals 42, what happens there? Well, it just says, oh, the variable number is pointing to a different value, which is 42. In that case, if I do type of number, which again was float before, this will actually show int. And it says, oh, okay, like, and it's not so much about what the variable, if I'm being a little computer sciencey, the reference is, it's saying what is the value that it's pointing to, and it actually looks at that value versus the actual pointing reference, which is a little different if anyone's here from like, you know, other programming languages. Other programming languages work more like boxes where you say this is going to only contain an integer number and you can only put integer numbers in there. In fact, the computer will yell at you saying, hey, you can't do that. Python's very loosey-goosey. You do whatever you want, man. Like, you know, it's cool. And I really mean like, it's like, it lets you do a lot of things that can get you in trouble. So for example, print is one that a lot of people get. Print numbers, like print is actually a built-in function in Python. However, I can do print equals 1. And guess what's going to happen? It works. Like it says, oh yeah, the variable print. However, if I now later on come over and say, hey, number equals 42, print number, it goes, whoa, you can't do that. And that's because print is now working as a variable. It actually overrode it. And that's because Python says, you know what, you do whatever you want. I'll listen to whatever you want. Do it. It's cool. Like, I'll trust you. And sometimes I shouldn't trust you. Python's very forgiving for you, but also at the same time, could get you into trouble. So if you ever get some issues like this, you'll see like, oh shoot, what's going on? It's actually great that Chuck that you brought this up because I know it's not exactly your question, but this is actually perfectly on there. Print now is now pointing instead of to the function print, it's now pointing to the number 1. So we can restart a kernel, and that can do kernel restart, and this will actually restart what's going on here. In fact, a lot of times you want kernel restart clear output, and it does the same thing like restarting the kernel, but just clears out this output. And basically, if you see, if I run this now, you'll see it says 1, and it starts fresh. So that way, if you come into a bind, you're like, oh, I messed something up, but your code's still good, but you just maybe ran something out of order or you did something silly like this, you can reset yourself. So there you go. And then I'll delete this because this is a foolish command. But yeah, but good question, Chuck. Hopefully, does that answer your question about though with number referencing and othering?
Thank you.
No problem. I will take a quick note is that this only applies, this is where Python is like, this is the debate about Python's like, you know, is it easy or is it hard? Is that this only applies when the variable is pointing or referencing to something called an immutable type. Immutable, IMMUTABLE, meaning that you cannot change it. A number, the number 42 is 42. You can't do anything to that. And so it will just point to a new immutable. If I change this to like, you know, 26 or something like that, or 27, it will point to a new immutable number. We'll talk about mutable ones, but one classic one is the list, which is with these square brackets. The list is immutable, meaning because you can add things to the list or you can take things off the list. It treats it a little bit different, and that's because the list itself, the number, like another number variable, is pointing to a list, but that list value can change. Versus like the number 2 is the number 2. It's not going to change. But what's in that specific list in this kite right here, it actually turns out that value itself changes. I know it's a little confusing right now, but maybe we'll see some instances of this and I can kind of explain a little bit more. But yeah, I don't know. Any questions? I'm sure there's questions about this, but anything say or sound pretty good? Not so good? Okay. I still have most people. All right. I think I have most of everyone. All right, cool. So some things to note about like methods and stuff like this. So we'll talk about methods versus functions. A method usually operates on the thing itself. So we have this variable called string. I'm going to call it, string right here. I can do dot title. So hopefully you guys have seen this already. You can actually say, okay, like what is the meaning of life? It actually title case it. You can also make everything uppercase, right? You can say, oh, here's the string, uppercase this. What's the meaning of life? Note that, what did we can do so here? String does not change. Note that this function is just saying, hey, take the string variable, the contents, and return the uppercase of this copy. So note that basically string itself is unchanged. It's just saying, oh, okay, essentially it's kind of like a method or a function that's like, oh, input this in here and return a copy. That's what's going on here, okay? I know that strings are a little different. Note that you, for example, if I tried doing this with something like number, which is like, oh, what would that mean? It's like, it won't work. So it's like, hey, you can't do that. Int has no attribute. So attribute.upper. So it's a method. Okay. Cool. Sound good? All right. Cool, cool. All right, delete that. All right, F strings. F strings are my favorite. They work in 3.6, if I remember this right, version 3.6 and above, which should be everyone's. They just make life a lot easier. If anyone's done Python 2, it's a huge mess to try to work with strings. So I've had my number 42, and I can say, well, what if I want to add like the number 42 within this? Like, what is the meaning of life? So you can see here, it looks like a normal string plus this extra stuff right here. I'm actually get rid of this F just to show you what this would look like. It just repeats exactly what I want. But it's like, no, I want it to say the number 42 plus 1. So I want it to be 43 here. So an F string actually says, hey, F standing for a formatted string. It says, hey, this is a special kind of string and you have a special formatting. And basically it looks for these braces right here and looks for code to execute. So I'll actually show you first what happens with just number. And so it won't actually print out number, it'll print out the value of number for that variable. In that case, it'll be 42. And in fact, I can actually add things in here, for example, +1 and 43. So it's a really convenient thing to be able to kind of reference that. If, for example, it's like, well, what if I wanted an F string, but also like this, let's say, for example, I had a number like this, but I also want to have like life like this. Like, let's say like I just want brace. I like the look of braces and I want that around life. This won't work, right? It says, hey, I don't know what life is. So you can actually do a backslash on these braces. And this will say, oh, no, this isn't like saying, hey, execute this code, actually print out the brace itself. You can see this here. Oh, wait. Maybe you can't. Oh, wait, I'm sorry. What am I doing wrong here? Scratch that. I'm going to have to think about that for a sec. See, everyone, even with me doing with Python for so long, I still get messed up. I'll have to look back at that. I don't want to spend too much time on this. All right. If someone thinks about it on there, don't don't try to figure it out like I was trying to figure this part out. I'm sure there's a way to do it. I just don't want to look it up right now. But anyway, F strings are really useful for actually putting in values from like integers and stuff in or not integers, from like variables and actually doing some operations here, which is pretty useful when you're trying to make a nice big old string. Okay, cool. All right, so that's kind of the main stuff is strings, integers, and then Boolean values, and then the none value too. So just know that none also exists in there, which can be useful. Pandas, which we'll see later on, will import missing values as none, essentially, being like there's nothing here, which is actually really useful to have. So we know it's like not just like, oh, it's not just 0, it's like actually missing. Okay, so data structures. Data structures are going to, like, there's a whole bunch of different things, but the main things we're going to talk about is lists and dictionaries. And between those two data structures, you're going to have pretty much everything you need to like really like organize data. Later on, we'll talk about this package called Pandas, right? Which we load data in. Basically uses a between lists and dictionaries to basically format the whole set of structures. So the first thing is a list, which is basically just 2 square brackets. And so we can do things, for example, just like list our values. So in this case, you can see here's the start of the list. In this case, there's a bunch of strings here. of different cities, and you can see there's all my different cities. And I can actually go and print this here. So I can save this as a variable, and I'll print this out, and you can see there's my list of variables, right? Or my list of values in that list. Okay. So that's kind of nice, but let's say it's like, oh, I just want the first 5 in this list. And note that this list is ordered. So like there is an order to this. It's not just like a mash of a bunch of different things. So I can do top travel cities, which is the actual variable, and go from 0 in this colon to 5. And what this is saying is like, hey, look at the list, and starting at 0, meaning the very first part, because we start counting at 0 in Python and in most programming languages. We start at 0 and go until the 5th one. So it will actually not include the number 5. It will actually, well, it technically, since we start at 0, right, we actually are counting to number 6, like the 6th one in the list. Does that make sense? So this is like 0, 1, 2, 3, 4, 5. It shouldn't include Albuquerque. And I could go here. You can see here, it stops at 1 right before Albuquerque. So this basically says start at the beginning of 0, and then stop right before you hit the number 5, which is the 6th one on the list. Okay, does that make sense to people? Cool. All right. So note that we can also see how big is this list by saying len, like the length of this list. So len of list is 11. So there's 11 different cities in here. Okay. Note that I put 0 before, but we also could have just had like this colon open like this, and it's just shortcut for Python saying, hey, like go from the beginning of the list to the 5th one, not including the 6th one, right? And you can see I get the same exact thing. So that's really useful too. So that way I don't have to type in the first one. Note that I can also do the same thing. For example, I can say, oh, I just want to skip the very first one. So that would be number 0. So I would say start at number 1 and go to the end of the list, right? And so that's what this empty part right here is. And I'll go to the very last one in the list, skipping over the very first one. Does that make sense? Cool. So this is called like indexing and slicing. So this is the different indexes. This is the 0th one, the 1st one, the 2nd one, the 4th one, so on, right? And this is actually slicing, saying, hey, let me get a portion of this list. And note that I could count from like the 2nd one to like, let's say the 5th one, right? And you can see I get a smaller list of this, right? So we're kind of slicing up the list how we want. Okay. So this guy is fun. So this one right here, so we'll kind of break this down. So we can say actually going from an empty colon, basically nothing, colon, nothing, right? What do you think this will do? Anyone got a guess? Go ahead and unmute yourself if you have a guess.
Shows the whole thing. Yeah,
shows the whole list, right? It says, okay, go from the beginning to the end, right? And sure enough, that's exactly what happens, right? We can see there's 11 different things here. Now this is a fun one. If I add an extra colon here, boom, that's actually telling us like how we want to proceed through this list. So I can actually say, count every other one. So note that I'm gonna actually pick a new cell just to make this clear. This is the whole list right here. And this basically says, hey, start at the beginning, go to the end, but count every 2. So you'll see it starts with Solta, right? And skips over every other one. So counting by 2. Okay. If I instead put 3 here, what will be the 2nd one on this list? When I run this guy.
Walla Walla.
Let's see. Yeah, let's see. That's it. See? Because it's going from the first one, and then it's going to the 3rd one. Or skipping over 3, going to the 3rd one, right? And go on. So that's pretty cool, right? Yeah. If I did 1 right here, what do we think would happen?
The last one. No, the first one. The 2nd one.
All right, good. I like all this. Cover all your bases. What? I heard someone else say something else.
No, never mind.
No, you sure?
Yeah.
Okay.
I think it's going to be the what?
So it actually shows the whole one because it's going counting by 1. So it's going to show every single one. Okay. So it's actually, if I do this, you'll notice that it does the same thing. So, okay. All right. Yeah, you ever see that? So you're basically saying like, how much do you want to count by? If I count by, let's say 20, you can kind of guess what this will turn. Because there's not 20 things in the list.
Nothing.
Just the one.
First
one.
The first one, yeah. So that's a little trick for you. Okay, who's ready to get their mind blown one extra time? All right, so what if I put, and you guys can answer however you want, -1. Will I even do anything?
The last
one, that's what I was going to say before.
Just the last one. All right, so we got
Yeah.
just the last one. Anyone else got any other ideas? I'm not saying you're wrong. Just kind of feel out and see if anyone else thinks anything different.
Count
reverse list,
backwards by
maybe.
one.
The reverse list?
Oh, I heard a reverse list. Ooh.
Oh, yeah.
All right, let's see, right? Yeah, it turns out it's reversed, right? So yeah, this is actually a really convenient way to reverse a list if you ever have it in Python. So you can see a little bit is that this first part, for example, if I go from like 0 to 11, that should be it. Oh wait, 10, because we have 11 things. You can see that won't work, right? Oops. I'll explain that in a second. We can 0 to 10 and say, okay, well, let's say 11, right?
Yeah.
There we go. And I say, okay, count by 2. Same thing as if I, oops, sorry, I don't know what I did there. Wrong button. You can see as if I could actually get rid of this. So like, oh, I don't need to do that. But you could actually say, oh, only a specific part. And that -1 just says, hey, going from beginning to end, reverse it. So that's the kind of idea here. What if I do -2? This is when your brain starts. Honestly, this is one that I would have to check myself just to make sure I got it right.
I think it's gonna start from the Toronto.
Yeah, they start from Toronto and then go every other one.
So and going backwards when you
Right, Toronto, Iguazu, Albuquerque.
Yeah, so it actually starts from PHA. So it's kind of confusing, right? Because like, wait, what's going on? And that's because it's actually starting from the end and going backwards, which is why when I did, if you guys notice, I messed up there for a second. I went from 0 to 11 and it gave me nothing because it's starting, I'm saying start at the beginning, but go backwards from there. Does it make sense? Let's see if this works. What's fun about Python, you can just play around and see if it makes sense. And you can see here, it's like, okay, it's saying, oh, go reverse from the order that you're having here. So you can do some funky stuff in there, but I would say is that this one right here, you'll see a lot of people use, is basically just saying this is reversing that list. Okay, cool. Yeah, that's a little fun one that I think is kind of nice to see. And again, this will come up again, especially in NumPy when we're dealing with data, because we want to slice the data up and everything like that. And you'll see a lot of things based around the slicing idea in Python. Okay, cool. Any questions at all? Hopefully showed you a couple things that weren't maybe you come across even you've seen lists before. All right, so I'll just kind of quickly go through this because I'm not going to walk through every part of Python, but I think you guys can figure this out. We have .pop, .append. Pop basically just says remove it from the list, but also grab that value. So that way it's really useful. It's like, hey, take it off the end of the list and then let me use that as something. .append, you're just adding it to the end of the list. .insert, you can actually insert a specific spot even, or you can just insert at the end. And then .remove, you can just remove it, which is different from pop because pop allows you to like pop it off and then keep it for yourself. Remove just like drops it off the list. And then .extend, I don't see this too often, but basically allows you to put two lists together so you can extend the list by whatever it is. So we'll start off with this A and B. So list A and list B, 1, 2, 3, and then also 1, 2, 3, but in string format. And we're going to do this one at a time. That way I can let you see a little bit what's going on. So we can see, here's A. Here is B. Okay, so you can see there's our different, and I do A.extend B. That will basically create this new A, which is 1, 2, 3, and then 1, 2, 3, which hopefully makes sense in string format. So note that this actually changes A. It's actually extending out A. So we're adding new elements. So if I just write now, if I just show you what A looks like, A is no longer just the numbers 1, 2, and 3. It's actually the string format too. Okay, that makes sense to people? Cool. All right, note if I do A.remove, say 0. Oops. Oh my gosh, I'm sorry. I was thinking of something else. All right, when you do A.remove, we want to say remove this number from the list. So I'm going to remove the number 2 from the list. And you can see here, if I actually write now the list here, you will see there's only 1 and 3. Okay, so I actually removed it from the list. If I do a.pop, okay, so let me just redo what a is. So now my a should be 1, 2, 3. Okay, a.pop is going to remove the very last one from the list, which is 3. But also, if I do x equals here, you'll see why I did that in a second. You can see a is now 1, 2, but if I actually put down x, it actually saved that value on there. So it's like popping it off and keeping it for itself later. I could have also done, if I did like a, so remember a is just going to be 1, 2, 3 now. If I do a.pop, you'll see it printed out 3 because there's no value there, but it does the same thing. So it just means that you can keep this value when you do it, this .pop. Okay, cool. And so there's a whole bunch of different stuff you can do. And then of course you can a.append. I can append like whatever I want to say, like, I don't know, the. And you can see here now, my a has the, right? And I can do that again, and again, and again, and again. You can see, I can just keep appending it, okay? If I do a.remove, what's that gonna do? It removes just one of the does. So good to know. All right, so, all right. I'll let you guys kind of be able to play with that. There's a whole bunch of different crazy stuff, which I'm not going to go into that. This is another way to kind of combine lists together. We can actually add lists. So a plus b. So just to redo this, okay, and we can see a is just 1, 2, 3, and then 1, 2, 3, and then I'm going to say this as c. So I can say a plus b plus the list of 100 to 100 plus 1. What's that going to do? And it basically just puts it together. So when we add lists together, it's actually just putting them all together in one long list. Does that make sense? And note that I had to put this number 1 right here in a list because lists can only be added up to lists. If I instead only did this, if it's one element, it's going to try to add a list plus a number, which Python's like, I don't know what to do on that. So you see, it'll actually give you an error. Say, hey, you can't concatenate, which basically put the list together, right? With an integer in a list. So that's what's going on here. Okay, makes sense? Cool. All right, and then note that you can also create like a nested list, which is a list within a list. So you can see here I have like this list, right, which is this whole thing, but inside this list, the very first element is also a list. You guys all see that? Okay, so I'm gonna make sure, okay, that's my a just to kind of show you guys what a is. So if I do this now, and we see what a is, which is what I just saved right here, we'll see that the first element is 10, 11, 12, and then 3, 4, and then another list, 1, 2, 3. So if I actually grab like the second element, which is number 1, that should print out 3, right? You say, there's my 3, right? And just again show you what this, if I grab the first element in here, this will actually grab the whole first element, which is this, which is just a list. So if I do this now, you can see there's a list right here. Okay, so let's say I had something like, I was like, okay, I want to grab C is equal to A0, which means like the first element, which should be the list, right? And say, okay, and then I want the first element in C, I would do that, right? And so this should print out 10. Everyone see that? So this is right here is grabbing this guy. And then C0, since this is saved as C, it'll grab this one right here because it's just looking at this whole list. Make sense? Okay, so you can see 10. But you can see that's kind of annoying. Like, I don't know if annoying is the right word, but it's kind of like a little like, that's a lot of typing extra. So Python lets you just go like this. It says, oh, I know what you mean. So the reason why it's doing that is because it's grabbing the very first element of A, which is this guy. And then from that result, which is just a list, grab the first element in there. It's grabbing 10. So if I change this to, oops, sorry, there we go. If I change this to the number 1, that should grab me the second element of the list after it grabs it, right? Which should just be 11. Okay. If I instead grab the 0, 1, 2, third element, right? And then grabbing the second element of whatever this is, which in this case is actually this guy, it should return 2. You'll see that? Cool. I didn't mention this, but you can also like I said, -1 lets you go backwards. If you just do a -1 as an index, does anyone got an idea what that is based on what you guys have already seen before or anything like that?
Should grab 2.
Yeah, that's right. That's right. Because just to kind of show you first, in case anyone is not following along, a -1 should give her the last element, which is this guy, and then grabbing the second element of that list, which should be 2. Good. All right. So this is a quick way to reference counting backwards, right? So if I did, let's say, I grab the last element in the list A, and then go minus, I'd say -2. That's going to count backwards, right, by 2, and so we should get 1. Or no, sorry,
Yeah, 2.
wrong. It should be 2. You're right.
Yeah,
-3 should get 1 because I'm counting backwards. Okay, so cool. All right.
And
So
if
some
you-
funky stuff you can do. Go ahead.
I mean, if you just grabbed, out of curiosity, A2, 2, it would get some sort of error, I'm assuming, right? Because you can't. So, no, I don't need to see it.
Exactly, because it'll say like, oh, that's not a list, like that's not subscriptable,
Right,
they call it.
Yeah,
So
okay.
yeah, good. So you guys are starting to see like where these errors are kind of coming from too. It's trying to let you know like, hey, there's something going on here. And you can even notice that in my code. It says, hey, right there, this is where the problem is. At least the computer thinks that's where the problem is. So it's trying to let you know. So good. All right, last thing, and then we'll kind of stop study group-ish, you know, and I'll keep it open for office hours for people who want to stick around, is dictionaries. So dictionaries is kind of like, they're usually talked about as key value pairs. I like to think of it as like a better list. So what I mean by that is that the dictionary doesn't have an order, but it has keys. So in a lot of ways, like a list actually has like a key value. So like the key is the number, is the index. Like, oh, the 0th element is the first element in the list. The key 1 is the, you know, the second element in the list. I know it's kind of confusing counting from 0, but the idea there is that there's a key and a value kind of paired up. Dictionaries allow you to use whatever key you want that's not necessarily in order. So that's why they don't have any order. If anyone who's like been in other programming languages, you might hear this called a hash map. They're basically the same thing, a dictionary and a hash map. Let's define a dictionary. So dictionaries are just like kind of like lists are defined with square braces. We have curly braces for dictionaries. And you can see here, this is the string key, or this is the key value, and then colon, this is the actual value. So I should say this is the key and this is the value. Okay. And then you can see this is the first element. Well, I shouldn't say the first element because there's no order, but the first element we define in the dictionary is going to be this str key and the value str value. And then I have another key, other key, and its value is 1. But I can also use 10, right, as the key, right, and the value is 5. Does that make sense? So that basically allows me, if I actually print this out, you can see what D looks like. And you can see that's the dictionary right here. Okay. And it's basically saying like, hey, my key references this value, this key references this value, this key references this value. So if I say get other, if you notice the kind of similarity to like list, it's saying, hey, using this key, what is the value that's associated with this key? In this case, it should be number 1. See, that's what we get. Okay. Pretty seem to make sense, like going through. One thing I'll note is that, you know, I can say like my list, like I'm making up like my list dictionary, and I can make kind of like what a list would look like and go like 0 is, you know, 100, 1 is 200, 3, or say 2 is 300. Okay. And I can actually do something where it's like, hey, like get me, you know, key 0, and that's 100. That's essentially what a list is doing. And in reality, it's just that everything's in order. The keys are already defined as 0, 1, 2, 3. But in a dictionary, you can do like, oh, I can do it when I'm out of order, or I can do like 10, or you can use other values other than just a number too. So you can see here is that I do like 10. Okay. Does that make sense? Okay. I wanted to show you guys that similarity. All right. So as a fun thing, you say, well, what happens if I try to get a key that is not actually there? Well, I get an error, right? It says, key is not a key. So that's kind of not ideal sometimes, because sometimes we're like not sure if the dictionary is in there, and we kind of don't want it to error. We just want it to, like, for example, let's say, for example, if the key is not in there, we want it to default to 0. it'd be kind of nice to have some kind of default value versus like giving us an error and stopping our code. So what we can do is actually doing this dictionary.get. So clicking up dictionary.get and then putting the key here. And this will try to actually, it will try to find that key. And if it can't find that key, it'll actually, by default, give you a none value. So if I print this now, you'll say none, which kind of makes sense, right? You're like, oh, like it's not in there. Like, so I'm looking for this key. It's not in there in the dictionary. Give me back none, right? And note that I did print here because if I didn't do print, it would just be blank. I think that's why I did that. Yeah, so that's why I did the print. But like you can see, that's really what's returning. Note that if I did something that was a key, let's say, what's the key in here? 10. It will just return the normal value that it should be getting. So nothing special. Another way we can do this is actually allowing for a special default. So for example, like I don't want it to be none, I want it to be 0. I can just say, hey, look for this key, and if you can't find it, return 0. You can see that's what happens here. Cool. Oh, Sam. Looks like Sam raised her hand. Thank you for doing that, because I can't see everyone at once.
Could you use the get value to get like multiple keys, or can it only be one key at a time? Or
ooh, interesting, right? I believe you can only get one key at a time, but a nice thing you can do is do help and do d.get. And you can actually see it's actually a little information about what's going on. Like this will actually tell you about the function. So it looks in fact that you can only do a key by one specific key. So unfortunately, yeah, that'd be kind of cool. But it wouldn't be supported natively. You'd have to kind of maybe create your own kind of code a little bit of like saying, if you want to need a list of keys, right?
Appreciate you.
So yeah, but you know, and if you didn't know how to do that, right, you can always Google it, or you can just try it, which I always like to do. Say, okay, let's say like a list of keys, right? Let's say we have 10, which we know is a key, and then we have like, what's the other one? String value, no, string key. Okay, and you can see here, hey, it doesn't let you do that. So it's because it's looking for, this is the key itself. And one thing I should note about dictionaries is that the key has to be immutable type. So you can't use a list to be a key value, or sorry, a key to the value. It has to be something that cannot change. So that's the reason why you can't have, like if I do something like, you know, d equals 1, 2, 3, and goes to 10, right? So like this would be like the key value. You'll notice that this won't work because like, hey, it's unhashable, meaning that basically this value can change by itself, which is why you can't do that. So that's why I can't do something like, and the reason why you might see this is something like this. See that? So the problem is that now I can change L, I could append to L and stuff like that, and the key no longer would make sense. So that's why I have to have something that's, you know, actually immutable. For example, I can have like the number 1, you know, and that would work fine. Or if I had, you know, this whole thing in a string, this would work fine too, because the string can't change. Okay, makes sense. Okay, subtle point to kind of be a note of. Assessing elements of the dictionary. Okay, just having a dictionary, we can count how many elements there are. We can get just the keys. So note that this gives a little dictionary keys, which looks like a string, or not a string, a list. It's not quite a list, it's close to it though. In version Python 2, it used to be a list. Now it's not, which there's a few reasons why. But you can see you can actually get the first element. For example, I can get the first element. Oh, I can't get the first element because there's no order in it, right? So what I could do usually, what you'll see a lot of people do is like convert this over to a list. So I'm casting it to a list. I'll call this like DL. My variable types or names are very poor because I'm just doing things live because I need to do things quickly. And you can see here, if I do DL now, you can see it's like a list. So yeah. And again, the reason why it's not a list is it doesn't really have an order. So you really shouldn't, like the Python programming language is not imposing an order on top of it. So you can still do things and treat this like a list, but not exactly. Okay. And then D values, you can see same thing, but it's just the value feed, actual values in it. And then D.items will actually do something called a tuple. So you can see like these dict items, and it's actually a tuple of values. So I'm going to convert this into a list just to make it a little bit easier for us to read. You can see here, each element is actually a pair of these elements, and this is called a tuple. Note that tuple, you can think of it like two things. Technically, you can have more than two things in a tuple, but it's kind of like the immutable version of a list. You can't append to a tuple. You can't remove from a tuple. A tuple is the thing itself. So that's why it's able to do this thing. But you can see here, if I get the first element in this like converted list of items, you can see it's actually the pair itself. And again, this is like a list, so I can get the first value of this thing, which will give me string key. So that's what's going on here. Okay. Does that make sense to everyone?
Mhm.
Okay.
And
Cool.
that's only because you've converted to a list already, right?
Yeah, yeah, that's right. If I did like let's just do this right real quick. And this is what's kind of great about Python. Like it's really hard to break things permanently. So you can play around with it and see what happens, right? But if I tried doing that exactly, you couldn't get it. I think I could do, let's see here. I think I can do a .get, but I doubt it actually. I never, for the record, you never do things like this. I don't think this is gonna work, no. The reason why you do this is something next called control flow, where we do for loops. So in Python for loop, you can do for I in a list like 1, 2, 3. Oops, missed my comma. And then you can do print I, oops, I like this, and you can print out each one. If you see like DL here, that's a dict items. I can actually loop over, just like I would like a list, I can loop over this dictionary items, and you can see that prints out. And that's the reason why it's structured that way. So we can still loop over it, but it doesn't have an order. So that's typically how you would normally see it. In fact, we'll talk more about this, but there's some fun stuff you can do. For example, you can do like your key and then your value for I in this part, and then print out, this will be the last thing. This will be like for next time in the future. I guess we'll see. So let's see, I have key, print. And we've seen format strings. We can see this is going to be value. I'll just call it val. And then this is going to be v. And then print just a new line. So I don't know if you guys have seen new line yet, but there we go. So what will actually happen is that it's going to say for each part in here, this would be a key value, but it does something called pattern matching. So it's actually going to try to match each value in here, string key with this k, and string value with v, and then same thing with this next one. And I can actually reference them directly. So you can see here, oops, wow, what's wrong with me today? There we go. You can see here is that I can actually reference that K and V because I know they're coming in pairs. I can reference it together. Note that if I had just V here, it would just reference both of them. Oops, I have to change that too. What did I do? Sorry. There we go. You can see here, if I reference them together like this, it's just going to be the pair itself, but I could actually reference those string pairs together and actually have them pattern match. This is a little more advanced for looping, but that's typically what you see. You'll see a lot of this kind of pattern in people's code, where you're basically matching this key and this string value. Cool. Yeah, how we feeling about this? Thumbs up, sideways.
Oh, that's fine.
That's all right. That's all right. I'd say if your head isn't kind of hurting a little bit at the end, then who knows if you really learned anything. But we'll go over more of this in the future for sure. In fact, this is going to be actually, I think, in the topic where we actually talk about like control flow and stuff like this. We'll see more of these things, but I'm just going to show you a little bit what this dict items is. But if you didn't catch this, that's okay. Don't worry about this specifically. This is the stuff that you should have kind of absorbed for the most part. All right, so it is what now 5 p.m. Eastern time, so quite a lot of time and everything. We're gonna go into office hours, but I'm gonna give you guys a little breather, and then you don't have to stay at office hours. If you're not staying for office hours, one thing I'm gonna have like your little assignment for the day is go through topic 1 and go through those first few lessons in topic 1 to set up your environment. I'm going to stick around here and be able to kind of chat a little bit for the next, at least for the next half hour. If you guys want to, like, if you already started setting up your environment and you just want some help, I know Sam had started that up, and we can go with that together. And sometimes it's useful to see what other people were doing too. But I'm going to stick around for a while for this time.